Hello everyone. Good morning. I am Jadip Kumar Shana, presenting one of my PhD research on titled A Novel Customer Sun Prediction Model for the Telecommunication Industry using data transformation methods and feature selection. Supervised by Dr. Muhammad Saifur Rahman, co-supervised by Professor Dr. M. Sohail Rahman. Outline. First, we will start from motivation, then application, and problem formulation, then literature review and research gap. Then objective of this study and our contribution, materials and method, result and statistical performance analysis, comparison with these studies, and then we will present why DT methods improve prediction performance. Then the discussion section and final conclusion. After the conclusion, we will present our future research plan. The motivation. Every business is related to the customers. Customers are the most valuable part of any business. Sometimes customer can switch services or even service provider. Such customers are called churn customers. Customer churn affects the company reputation, company public view, and of course, losses potentially large revenue source. Generally, industry follows two main strategies. One is increase the retention period of customers, and second is acquire new customers. It is believed that the most profitable strategy is the first one. Now, the application, as I said, most of the business is related to the customers. So, telecommunication industry, shopping, software service, hosting service are the customer. There is a customers and there is a probability of churn prediction, customer churn prediction. Our research focused on telecommunication industry. Problem formulation in telecommunication industry, customer historical data usually stored in customer relationship management system. This data can be used to analyze customers' behavior. Customer prediction model predict the probability of the customer churn. If a company can identify the customers who are likely to churn, then they can take necessary action and reduce their dissatisfaction and increase their retention period. The customer prediction problem is the binary classification problem, namely churn and non-churn. Now, the latest review, many machine learning models have been used to tackle the customer prediction problem like recently random forest, fit for network, map base, etc. This slide shows few previous studies where reference study for use log rank data structure method. Reference study 12 used discretion and whatever evidence data structure method. Reference study 5 uses log rank, box, zero score, and reference 5 and 4 use intersection techniques. And now the research gap from the previous table, it is clearly mentioned the limitation of the previous research, and they are more most of them are conducted on one or two data set. Only 3 period are related to the data transfer method, and only they use only 2 or 4 data transfer method. Another limitation is the impact of data transfer method combined with the classification and optimized machine learning classifier has not been investigated deeply. So there is a large room for exploration of data methods in conjunction with classification and optimized machine learning model. And our beauty of this research, we tried to close this research gap and propose a optimized machine learning model which can potentially outperform the Institute of Art Models. Now, our contribution, we develop several customer prediction model using data transformation method and machine and learning classifiers. We use classifier algorithm, KNN, naive Bayes, list regression, random forest, decision tree, gradient boosting, feed forward neural network, and weekend neural network. We also use 6 data transformation method like log, rank, box, zero score, discretization, and node evidence. We also use univariate technique to select the features. We also use the gradient and grid search for tuning the hyperparameters. Our experiment conducted on 4 publicly available datasets, and the evaluation metrics are AUC, precision, recall, and measure. We also perform a statistical significance test, and finally, we provide a concrete decision on the best combination of DT methods and prediction model. Now, the materials and method datasets. We use 4 publicly available datasets. The number of sample size of dataset 1 is 1 lakh, and for dataset 2 is 5,000, for dataset 3 is more than 3,000, dataset 4 is 7,023. Dataset 1 is the balanced dataset, and dataset 2, 3, and 4 are the imbalanced dataset. This is the process of proposed customer prediction model. After reading the data, we perform few data processing technique like data cleaning, missing data replacement, and category encoding. We use label encoder for category encoding. After data processing, we use 6 data source method. Here is the original data set. After applying the data transformation method, we use univariate feature selection technique and select the higher scored feature. Then we use grid search to find hyperparameters of the classifiers. After training the model, we evaluate our model with careful qualification in terms of AUC, precision, recall, and measure. Now the data transformation methods. For the log transformation method, when data value x is 0, the value is 0, and then when the greater than 0, then we use 1. For the rank data transformation method, we use 10% rank. For the box plots, the lambda is equal to 0.5. We use constant Z score as a data transformation method. And for discussion, the mean value is 20, and the probability is the log of proportion of event and non-event for a exponential bin level. We select the high score feature using univariate feature selection technique, and it selects the best feature using the univariate statistical test. For the dataset on, we used 18 features. For dataset 2, 3, and 4, we select 15 features for our model training. Now the hyperparameter is the model parameter whose value are set before training, and we use grid search method to select the optimal hyperparameters, which actually provides optimal combination of hyperparameters that achieves highest score. This is the hyperparameter value we set for our model training. And this is the graph that represents the how hyperparameter optimization is is conversing using the grid search. When the C value is 5, it provides the highest score. So we said C value C value is equal to 5 for investigation classifier. It is the 3D graph for people neural network, and when the pickup size is 10 and best size is 10, it achieves highest score, and that's why we said pickup size is 10 and best size is equal to 10 for the model train for model train. Now the result on data set on this heat map represents the 6 data transformation method and 8 classification method. Also we have the raw method. In this AUC heat map, we see that within this we can find a random forest, linear regression, fit for neutral network, and gradient boosting achieves better performance result. We in terms of F measure, we also found same result pattern. For the precision and recall, we also found weight of evidence provides the highest result. However, when we see that raw-based reference provides better result, but when we observe the precision value of raw-based reference is very low, so it is not an issue. For the data set on, the best performance interpret measure is raw-based reference is 0.61 and weight of evidence-based reference is 0.8. Now, weight of evidence-based reference achieves 30% improvement in terms of AUC, and in terms of F measure, the weight of evidence-based reference achieves 13.9% improvement. For the data set 2, we observe that weight of evidence is the winner and second winner is the Z score. For the data set 3, we also observe the same result pattern. Where weight of evidence is the highest score, provides highest score, and Z score is the second winner. For the data set 4, we also found weight of evidence is the highest score. However, the second winner is the raw. So we observe that weight of evidence achieves most constant performance across the all data set. That's 1, 2, 3, and 4. Now, the estimated measurement test. For the statistical test, we used Friedman non-parametric statistical test. It does not assume any particular distribution, and the test was carried out with significance level alpha equal to 0.05. Now, null hypothesis is there is no difference among the performance of Patterson prediction models. Here is the statistical performance analysis of Friedman statistical test. This is actually rank value. The weight of evidence model achieves position 1, and the Z score is the second, and raw is the third. So now this heat map actually shows the performance difference among the DT methods in terms of p-value. The p-value, when the p-value is less than or equal to 0.05, we consider there is the evidence of significance there. So from this heat map, we found the weight of evidence has the significance. There is the significance difference than the other DT method, except the Z score. We also found that log and raw performance has a significant difference. So from this previous two study of, statistics, we performed again the Friedman home post-hoc analysis. Here, this table shows how weight evidence is different than the other teaching model. If you consider alpha, significant level alpha equal to 0.05, we observe that with the except the Z score, weight evidence has a significant difference than the other method. If we consider significant equal to 0.5, we also see that the weight evidence and the score have a significant difference. Now, the comparison with other study, we compared our study with other state-of-art models. In our study, weight evidence here the data set are the same, and we have common performance metric. For our study, weight evidence-based opinion achieves 0.8.02 in terms of AUC, whereas for the reference defined, it was 0.54. For the in our study, the weight evidence-based opinion, the F method value is 0.8, whereas the reference study one, it is 0.63. So in terms of AUC, our model achieved 26.2% improvement, and in terms of weight measure, our model achieved 70% improvement. Now the question is why DT methods improve prediction performance. This is a QQ plot for data set on where we use first two officers. When we applied the weight of evidence and data score on the officer, we found that we have better quality data, and the data become more reliable distribution. For the data score, we also achieved a slight improvement of data quality. For the data set 2, we also observed the weight of evidence and data score provides more quality data. And discussion in the in our research, we use 6 different data methods and 8 different machine learning classifiers on 4 publicly available data sets. We perform comparative analysis and statistical tests based on the statistical test. We can see that weight evidence-based state-of-art classifiers have a great impact on improving customer prediction within the telecommunication industry. Weight evidence-based linear regression, random forest, fit for neural network, and gradient boosting classifiers shows the remarkable improvement. And this is because the weight evidence data spent with the next weight transform are into more normal distribution. Some few prior work reference 34, 5, and 12 uses a limited set of data and conducted on one or two data set. On the other hand, we explored many data transmission method on several data sets, and we demonstrate the supremacy of weight evidence across the several data sets. In few cases, weight evidence-based models fail to outperform the raw-based models. However, the degree of outperformance is relatively very low. For example, if measure in terms of F measure, the weight evidence gradient boosting is worse than the raw-based gradient boosting by only 4.2% for the data set 4. So we hypothesize that this is due to the small and imbalance data set, because data set 4 is very small and it is imbalance. If you consider for the data set on, weight of evidence provides the constant result across all the classifiers. This is because it is large data set and the rate of evidence decreases. The weight of evidence is opinion achieves 30% improvement in terms of AUC, and in terms of page, I see 30.9% improvement than the drawbase agreement. We also observe the notable performance improvement for all the data sets, especially for raw and FNN. So we recommend whatever the linear regression and or fit for neural network to construct a successful customer configuration model. Now the conclusion, in most cases, whatever vision generators code data because actually enhance the data quality and improve the prediction performance, and the performance are the significantly better. To support our experimental result, we perform parametric statistical tests and post-hoc analysis. We also compare our approach with other two state-of-art techniques, and we observe that our proposed approach models provides the better result. To test the robustness, we also perform experiment on both balance and imbalance data set. So here are few research directions. This our proposed approach can be tested on other frequent data set and to generalize our claim across the other business domain. This approach can be implemented on customer churn data for other business sectors. Now our future research plan. Yeah, the evidence shows remarkable progress for churn prediction. We can use weighted evidence in a research domain where privacy is the main concern. For example, privacy preserving customer prediction. We all know that is the main fuel of any machine learning model. However, a dataset may contain sensitive individual records like health record, financial record. These data are privacy sensitive both for the legal and ethical context. When training a model with this sensitive data has become so training a model with using this sensitive sensitive raw data has become a new privacy concern when someone uses third-party cloud computing. Privacy can also compromise with the dishonest and curious service provider that also be compromised unintentionally due to the data diversity during the computation time. Training model also suffer privacy attack and leaks sensitive information. So we would like to propose a framework for privacy preserving customers and prediction model in the cloud environment. We want to use generative and visual network and modified weighted evidence for our targeted privacy preserving customers and prediction framework. As the references, thank you.